Let's take a look at this example. We saw that the Kaiser window at least fulfills the requirement for the attenuation of our downsampling application example. How do we get the correct start of the stop band for attenuating the aliasing for downsampling sufficiently using our filter design method? Our stop band should start at 0.5 for a downsampling factor of n equals to 2. Looking at the Kaiser window with beta equals to 8, we see that we get minus 60 dB at a normalized frequency of about 0.36. Hence, our ideal filter needs to have the end of its passband at 0.5, it's our desired, minus 0.36, that it's equal to 0.14. Remember here that 1 is the Nyquist frequency. Hence, our omega for the stop band should be 0.14 pi. Observe here we need the multiplication with pi, since for our formula pi is the Nyquist frequency. Now we just need to plug this into our formula for the ideal filter, the sinc function, with L equals to 16. So here we have our formula, and we will plug in the 0.14 pi here, and we are using L equals to 16, so we have this 7.5 here and here. Or we can have a different formulation with normalization to let the passband start at 0 dB. So we have this formula here, and then omega c should be equal to 0.14 pi, and then we multiply it with our Kaiser window.